Everyone, I am going to give seminar over mean value analysis and related techniques. So under this we have to discuss about this four topics like analysis of open queuing networks, mean value analysis, and approximate MBA and balance job bounds. So coming to analysis of open queuing networks, it's used to represent transaction processing systems such as airlines, reservation systems or banking systems. So transaction arrival rate is not dependent on the load on the computer systems. So arrival models are as the Poisson process with a mean arrival rate lambda. So exact analysis of such systems. So assumptions. There are some assumptions. So all the devices of the systems can be modeled as either fixed capacity service centers, single servers with exponentially distributed service time, and delay centers. So infinite servers with exponentially distributed service time. So analysis of open queuing networks, we have certain formulas like for computing that response time, that is equal to service time into that is 1 plus q. We have whatever the queue length we have. So on the arrival rate means we have a total response time of si into 1 plus qi, and we have certain assumptions here. Service of is the memoryless, and it's not operationally testable and not an optional law. Mean performance, coming to this topic, we have assumed like job follow balance, and their arrival rate we have x is equal to lambda, and the throughput of the IR device using the first flow law is xi equal to xvi. Then the utilization law of this IR device, using the utilization law we have ui equal to xi into si, and that is further expanded to x into vi si, and that is equal to lambda di. So the q length of this IS device using the Little's law is like we will get like qi equal to xi ri, and xi that is equal to xi into si into 1 plus qi. Here we are replacing this ri with the previous formula what we have for the response time, and finally we are getting like qi equal to ui into 1 minus u. And here we can notice like qi is identified to the equation for the mm and 1q, like that is like we have a q that is exponentially distributed, and uh, we have only one server, and this m represent for arrival rate, and this is for service rate. The device response times are further calculated, and that is ri equal to si minus that is si divided by 1 minus ui. And now we have in delay centers there are infinite servers, and therefore that ri equal to si and qi equal to ri into si, and it is further we are getting that is equal to ui. And this is the example where we have one CPU and two disks, and this is means it's consisting of six client systems, and we have formulas, and we are calculating like observation interval is like 3600. We have data, and number of client request is 10,800. So CPU busy time we can calculate how much time means for what time it's CPU is busy, and that is coming to 1728 seconds. Disk A and B busy time we have further calculated, and we are miss all the time when the disk is busy, almost that CPU will also be busy for calculating, and that's what CPU busy time will be more than the disks. So further we have these are the okay. So here we have all the means assumptions, and we have calculated this. So with this I over with this for seminar.